Hi, everyone. This is 3-3. So we're looking at measures of relative standing in box plot. So kind of a weird title, but what we're really looking at is like, how far is my data away, my data value away from everybody else? So how can I compare me to everyone else? So we can use percentiles like I'm in the 90th percentile, right? Or those kind of words. We have to figure out how to calculate that. We can also use a z-score, which is what we see on the screen right now. So those are kind of where we're headed. So the first idea here is a z-score, and a z-score is how many standard deviations are you, like, is your data value. So we do that with this formula here. They're the same thing, right? If I have the full population, we just use the mean of the full population and the standard deviation of the full population. They just have the different symbols, right? Because you have everything in that population. Where this is typically our world, because the likelihood of you getting the full population in your data set is pretty unlikely. So sample, this is our mean of our sample. This is our mean of our, or standard deviation of our sample. So we need our data value, whatever it is, whoever it is. It represents one person or one data value, mean and standard deviation. And what this z-score is going to tell us is it's how many standard deviations away from the mean are you? So you always have your mean in the middle, right? And we know if we go one standard deviation out, we're picking up 68%. So if you're beyond one, you're pretty far off or below or above, right? And then if you're even out more, then your that data value is way lower, way high. So that's what this is trying to tell us here, is the z-score is the number of standard deviations away, and it's expressed with no unit of measurement. It's just a z-score of 2, a z-score of 3. And you have to know it's how many standard deviations away you are. A data value is considered significantly low or significantly high if it's above or below 2 standard deviations. So that's like way out there. Okay. And then the last little part here just says if it's negative, it's below the mean, right? You're below the average. So let's say I'm just amazing at taking tests. Totally a lie. I should go the other way, but that's okay. And the average was a 70, and I'm at a 99% on my exam. I am probably significantly high. I would have to do the data and do the z-score, but that's what we're looking at, because I'm going to be at least 2 standard deviations away from the middle. Okay, so let's look at an example. This one says, which of the following 2 data values is more extreme relative to the data set from which it came? So this first one, 4,000 is the weight of 4,000 grams is the weight of a newborn baby among 400 weights with a sample mean of this and a sample standard deviation of this. So we're going to take this 4,000, that's our data value, and we're going to subtract the mean, which was 3,152, and we're going to divide by the standard deviation. And this is going to give us our z, right? Our z-score. Can't quite fit that in there real well. And I'm going to just grab my calculator and calculate this out real quick. So I'm going to take 4,000 and I'm going to subtract 3,152, no decimals on that, and then hit enter, and then I'm going to divide 693.4, and I get about 1.222. So I'll do 1.2. We can go, I think they usually like 2 decimals, so let's do that, 1.22. I think the standard rule is 2 decimals out for z-score, but in your homework it'll tell you what to round to. So the next one, the 99-degree temperature of an adult among 106 adults with a sample mean of this and a standard deviation of this. So if I have a temperature of 99, and then I'm going to subtract the mean of 98.2, and the standard deviation is 0.62. So 99 minus 98.2 divided by 0.62, I get about 1.29. So which one is more extreme relative to the data set it came from would be this one, right? Because its standard deviation is larger. That means that data set or that data value is more extreme. It's further from the mean, the middle. Okay. Here's just a little chart that I liked from the book that I stole. And you can read the textbook too. You can always open the textbook through Pearson lab and read it as well. Okay, so this is like significantly low, significantly high. It just kind of helps you with what's high, what's low. Okay, so I liked this. Maybe it's confusing to you because it has so much information, but we know in the middle here, right, is our mean. And so this is our mean right here, right? If I have a value, a z-score, that is exactly where the mean is, how far away from the mean am I? If I'm right at the mean, my z-score is 0, right? Because I am not deviating from the average. I am right there. So if your value is right on the mean, then your z-score is 0. Okay, and then this is like 1 standard deviation out. Okay, 1, 2, 3, and so forth. And so if you're in this section below the 2, right, or above, either one, that's our extremes. And you can tell, like, everybody's here. If you're out here, you are significantly high and low. Okay, so take it for what it is. It's got lots of stuff on that graph. I just liked it. I'm not sure why. Okay, the lowest platelet count in a data set is 75. The platelet counts are measured in 1,000 cells per UL. I'm not really sure what the UL is. Is that value significantly low? Assume the platelet count has a mean of this and a standard deviation of this. So is 75 significantly low? We know it's definitely low if the mean is 239, but is it significant? So again, we're going to do the z-score. So we take 75, our value, subtract the mean, divide by the standard deviation. Let me put that in my calculator. And I'm going to get negative 2.56. So yes, this is significantly low. Because it's below -2. So it's negative 2.5. So if you're at -2 or below, you are significant. So yes. Okay, so those are all z-score stuff. Just maybe make sure you write that formula and what z-score means on your note sheet for the exams and the quizzes. The next idea is percentiles, and this can be a little bit confusing for a lot of people. What percentile are you in, or is your data value in? So they are measured by location. That's exactly how they're measured. So you're going to divide a set up into 100%, and then 1% is each value, right? So basically, we're looking at your place in your data set. That's what we're looking for. So if everybody took my exam and I have 50 people or 25 people, is more realistic, 25 people, where are you percentile-wise in that group? That's what we're kind of looking for here. So I don't love this, but this is what the book has, and it's what's in your example. It's okay, I guess. It's the number of values less than X. So if I'm in this spot here, this is my spot. I count how many values are below me and divide by the total, and that's going to give your percentile. They times by 100 because you got to move your decimal 2 places. So I don't like that piece on there. You should know if I get 0.12, that's 12%. Right? So that's just part of it. So you count the number of values below you to get your percentile. So let's do that. Look at this graph here, and this is the airport Verizon cell phone data Excuse me, are arranged in increasing order. Find the percentile for the data speed of 11.8. So here's 11.8 right there. How many values are there below it? Well, this is 50 data. There's 10 each row, so 20 below. And there's 50 total. So I'm going to take 20 and I'm going to divide it by 50. So 20 divided by 50 is going to give me 0.4. And we times that by 100 to get 40%. So that value is in the 40 percentile of the data. So count how many below. Okay. So there's a little bit of a notation using the same data. This notation right here is saying what value is in the 40th percentile. Okay. So what value is in the 40th percentile? So this one's a little tricky. So I wrote the notes out from the textbook on the bottom there for solution for 4. So what they want you to do if you're finding a percentile, I don't like that they picked 40 and 40, but that's okay. If we look, we can think of 40th percentile and we got to figure out where the place is. So I have 50 data. So I'm going to think of as 40% times my data, right? So percent times the number of data sets, right? So that's going to give me 20 because I think that's what right? That's 20, yeah. So 20 values in. The hard part is we don't have 100 for like a pretty number. So if I had 100 data, it'd be even easier. I'd just go the 20th one and we're good. But we have 50 data. So if we count, the 20th one is here. Okay. And what they want you to do is average the 20 and the 21st. Average those two. So you found the place, the 20th place, the 11.6, but you have to average those two because it's not an even 100, which really confuses people, but just average. All you do is times what percent you're looking for by the number of data in your set, and then you average that exact one in the next one. So we would take the 11.6, right? Oh, yeah. And we would add it to 11.8 and divide it by 2 to get 11.7. The 40th percentile number is 11.7. It's not even on our data set. But according to this data set, this would be the value that would be in the 40th percentile. Okay, I'm not going to deny this. I'll be emailed this exact question from your homework a lot. Okay, it's all about the place in your data set. So if I say you're in the 99th percentile when you take a test to get into the nursing program, you are amazing. And that means out of everyone that took that exam, you are way above them, right? So that's kind of how that works. So on the same lines is a box plot and quartiles. So breaking your data now into 4s. Quartile, quart 4. So I can break my data into 4 sets and kind of look at it. And that graph that makes it into 4 pieces is that box and whisker plot or box plot. So here are some ideas that kind of go with that box and whisker plot. First quartile, we kind of denote as Q1. Second quartile, Q2. Q3 is the third quartile. And then we don't have a higher one. When you break your data into 4 pieces, you're like, here's 1, 2, 3, 4, right? You have 3 numbers to break it into 4 plus the high and low, okay? Which is called the 5-number summary, almost there. So those are denoted there. And you can see it's the same as P25, P50, P75. You are in the 25th percentile, right? 50th percentile, 75th percentile. That's what they represent. Here are some more things that IQR comes up because it helps us with outliers. So that's just the range of the middle 2 quartiles. So quartile 3 and 1, you subtract them. It's like the range of the inside. That becomes important for finding outliers because it's part of the formula. All right, and then those are just some different little mid quartile range, semi interquartile range, just different values that some statisticians use. Okay. The big one for us will be the 5-number summary. These are the values that go with the box plot. So you have to be able to find these in order to draw your box and whisker plot. So in order to break something into 4 pieces, I actually need 5 numbers. I know, it's so weird, right? But you need the start and stop, and then to break it into 4. So just think about it like this, right? If you have to have 1, 2, and then to break this into quarters, I need 5 numbers. That's the 5-number summary. So you can see it's in quartiles. It's in 4 pieces. So we have the lowest number in your data set, and we have the highest number in your data set. Then the first quartile is here. And then your second quartile, which is actually the median, right? Because you're breaking your data into 4 pieces. And this one's quartile 3. This has nothing to do with what numbers are in your data. You're taking them and breaking them like, I want equal amount in this set, equal amount. So there's equal amount of data values in every quartile into 4 pieces, because you're just breaking your data into 4 pieces. Okay, so I say on here, I'm going to show you in Statcrunch. I'm actually going to wait and show you in the Stack. Properties of a box and whisker plot is it shows skewness, like it shows maybe this lower half of your data is really squished together, so that box plot will be skinnier, and then maybe the upper part's wider, and so it shows that specific quarter of your data is more spread out. So the longer the section, the more spread out it is, the squished together, the less spread out that data is. So it's showing distribution in each quarter specifically. Like a histogram shows distribution of the whole thing. This is showing each quarter specifically. So we like these on standardized exams. You will see it in Canvas. It gives you a box and whisker plot with your dot where you are, so that you can see where you are compared to the rest of the class. If you're in the upper, you will see the little line and your value will be way up high. Now I want to show you that, but I can't because the only way I could show people's names in the grade book. Can't do that. So just click into your grade book. You will see that if you click the detail button. All right. So that's kind of what the box and whisker plot shows. And then I go into outliers here. I really want to draw a box and whisker plot before we go further. So let's go ahead and do this one, and then I'll talk about outliers. So let's do this example. So here's our data set, and we need to make a box and whisker. So I need the 5-number summary. So we need the 5-number summary. I put this on the final exam, and about half my students remember and half don't. So morning, yeah, if you watched this video, I just told you this is on the final. Okay, and on your next exam, obviously, but 1, 2, 3, 4, 5. Those are our 5-number summary, right? So the first one is the lowest number, which is 0.8 right here. And the highest is 77.8. Okay, then how am I going to get the other ones? I'm going to find the medium. So median. A medium would be a person that tells you, talks to the dead for you. Not quite the same. Okay, 1, 2, 3, 4, 5, 6, 7. Okay, I suddenly was like, is this not in order? It is in order. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So they are 10. Okay, so I have 50 data. So I need to count about 25. 1, 2, 3, 4, 5. And I'm going to draw a line right here. That, can you visualize that that's breaking them in half? So the median would be the average of these two. So I have to do the median first. You just have to. So 37.7 plus 14.1. And I'm going to divide that by 2. And I'm going to get 13. Oops, that's the median. 13.9. is our median. Then the quartile, first quartile is halfway between the bottom two. So the median of the other two, so that's going to be about 12 data, right? Because it's 25. So I think 12 plus 12 is 24 plus one extra. So about 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I'm thinking this is right in the middle. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's 12 values before, 12 values after. So that's the exact middle. And so that one is 7.9. So when you have an even amount, the median is an average, but the other two are exact places. So same idea for this way. I got to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this one, 21.5. So that's how I broke my data into 4 sections. So section 1 is here, okay? Section 2 is this values here. Section 3 is going to be these values here. And then we have the last section, which would be these values here. So 1, 2, 3, 4, 4 colors: blue, red, purple, green. We broke our data into 4. Now, is it easier if it's in a straight line? Yeah, because you go median, half of this, low and high. But typically, if your data sets are big, you're going to look something like this. Okay, let's do this in Statcrunch. So I'm going to open this up on my, if it doesn't come up real clear, I'll open it on my computer. But okay, so data sets in here. Couple things I can do. I haven't drawn the, but I'm pretty sure this does the box. Let me double check. Oops, I have to sign in. Hold on. Dun, 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 dun. Signing in. Okay, so I thought that, oops, I didn't mean to click that, that it had summary stats, column, data speeds. I thought it had like the exact, maybe not. Okay. So let's just go to the box plot right here, which we haven't drawn by hand. I'm going to make us do that too. And we have to pick our column, which is data speeds. It looks a little bit different on the computer. It's just like a box. You have to still pick your data always on the top one. And then let's just compute and see what it comes up with. There's our box and whisker plot. So of this data set. So we can see low. I wonder if we can touch it and get the 5-number summary. No. Okay, so that's kind of what it looks like. I want to bounce back real quick. So if we draw ours the way we have it right now, ours by hand, right? I don't really care which way we go. They always draw them this way. I always draw them the opposite way. But so if we think of 0.8 is going to be, so maybe we have 1 here. So 0.8 is a little lower. And I'm going to put a dot there at 0.8. And then 1, we have to count to 77. So this would be 0. I don't want to count that big. Ooh, let's not count that big. We'll be in trouble if we try to count that big. So let's go 0, 10, 20, 30, 40, 50, 60, 70. And then we would go 0.8, which is like super low, 7.9 about here, 13.9, maybe here, 21, a little over 20, and 77. I didn't even go high enough. 80 is about here. So the middle 3 make a box, and they go out to the ends like this. So if we made it by hand, it might look like this. And we can see that this is way more spread out. This data is. And I can look and see these 70s are way bigger than the other values, and maybe even the 55. So this is a common one. This is not a modified one. If we look at what was just created in Statcrunch, we can see that does not look the same. So that's why I have to go back and talk about outliers. So Statcrunch does make a modified box plot right here. Maybe I'll highlight that modified box plot. I don't want to like green. Okay, so what it does is it finds our outliers for us and it denotes them by a dot on the graph. So when I draw it by hand, I would draw the line all the way to the end at that 77 or whatever it was. But on the program, what it does is it figures out in Statcrunch what are an outlier, and they leave those off with a dot, and then they make the box and whisker plot with the data that's not considered an outlier. And we have an official way to find out if something's an outlier. We take the interquartile range, okay, and we're going to times it by 1.5. And if we then add or subtract that to our quartile 1 and quartile 3, then we can see whether or not it's above or below. So let me visualize that for you. So we have our quartile 1 right here-ish, and we have quartile 3 right here-ish, right? And this is the median in the middle, and you have your low and your high. So basically we take 1.5 times these two subtracted, and then we minus it this way, okay, and we add it this way. If that value is above or below what we have added now, it is considered an official outlier. So for this data set that we have here, we can take the two values that are our Q3 and 1, Q1, Q3, and we'll subtract those. So 21.5 minus 7.9. That is an interquartile range. I'm going to write that here. That's an IQR interquartile range of 13.6. If I times that 13.6 by 1.5, so I'm going to times that by 1.5, I'm going to get 20.4. If I then go back to my highest number at the quartile 3 and I add that, so looking at the high side, I'm going to go 20.4 that I got 13.6 times that, and I'm going to add it to the 21.5. And again, that's from the quartile. And I'm going to add that 21.5. That's going to give me the value of 41.9. Anything above 41.9 is considered an outlier. Oh, so all of these are considered an official outliers. All four of those are. Okay, let's look at the low side. So we still have IQR times 1.5, which is this, but this time we'll subtract it. So we have 7.9 is our quartile on that side. So we take 7.9 and we subtract 20.4. 7.9 minus, it's going to be in the negatives, 20.4 is going to give me negative 12.5. Do I have any numbers that are negative 12.5 or below? No, we don't have any negatives. So there's not a lower one. There's just an upper one. So look at what it does for us. Those are our, did we say, hopefully we said there were 4, right? 1, 2, 3, 4, yeah. Good thing we match. Yay. Okay, so we match what we just found. See those 4 dots? Those are our 4 outliers. So that seems like a lot. You're sitting there and you're doing your homework and you're like, I don't know if this is an outlier. What kind of graph could you make on Statcrunch to see if it's an official outlier without timesing by 1.5 to the IQR and adding or subtracting? You make a box plot. It'll tell you if it's an official outlier. So when you go to do your data for your projects and for your labs and you say, oh yeah, that looks like an outlier, it might not be. You have to actually test if it's an official outlier. Okay. All right. Clear as mud. So it's kind of cool though. I love that Statcrunch does the modified box plot for us. So it's like it's taking this right here, and it says, okay, this 43 and this 55.6 and the 71 and the 77, they're all outliers. And then I can't remember where, if it does the middle, it stops it somewhere in here and only does this part too, that like one lower. I don't remember how it does that value. It's whatever value, it's probably to the 38.5 is where it goes. Okay, it is, it has to be. And it goes to this number here instead. Yeah. Okay, so that's the modified is what I covered in the blue there. We kind of end here if it's modified instead of going all the way out to the end. Okay. Using the following data, find the 5-number summary for both men and women. Where's the data for that? I know where the data is, but I did not add it on here for me to click into. Okay, so let's do, I'm in my Statcrunch, close this. I'm going to go over here to my data, and I'm assuming data speeds, trimmed data question, coffee by gender. I don't know if we could do coffee men and women. Sure. Here we go. This is coffee times by men and women. And let's go ahead and make our 5-number summary. So we're going to go to summary stats, and we're going to go to the column, and we're going to tell it men or women. We could do men first. And then the items that we pick are, it comes a little different, right? You can use shift or control to like click more than one, but like I don't want all of these. I want the median, I want the min, max, and the quartiles. That's our 5-number summary right there. It also does IQR for you, but here's your 5-number summary, compute. So for men, it doesn't quite do them in order, but we can see that we have the min, the max, the quartiles, and so forth. Let me do something different here. Go like this, split screen, Chrome. I just learned this. Okay, so for our men and women data, we can say, well, the men's 5-number summary, 1, 2, 3, 4, 5, will start at our lowest value is 40. Our quartile 1 is 85. Our median is 120. Our quartile 3 is 140. And the max is 370. It looks like the men might have an outlier. Okay, and then for the women, what's kind of cool is you can go to options, edit, and you could just switch the data set to women. You could do them both at once too. That's kind of a cool idea. So I don't remember if I can see, and then compute. So there we go. It does them both for us. That's even cooler. So then for women, the lowest value was 55. And then the quartile 1 is 110, and the median was 140 for women. And then the quartile 3 is 215, and the highest value for women was 360. So we can, you'd still just have to go to stat column, and you have to just pick the things that are in the 5-number summary. It doesn't just pop it out for you. You have to actually look. And so it helps you know what's in the 5-number summary, okay? Is understanding min, max, quartile 1, quartile 3, median, and quartile 2 is sometimes called the median. But okay, I am going to go to close. I'm going to go to graph, and I want to see what the box plot looks like. And I'm going to pick both of them and make them do both at the same time. And there we go. We definitely have an outlier on men, no official outlier on women. We can see that the women is way more spread out in the higher. So it is taking women way more time to get their coffee than men. So obviously the baristas on this data set prefer to hurry men along, and women, they can wait. Other than the one man that was the outlier. So you can see the data is more spread out. You can see the medians are the line in the middle. The medians, women's median time is higher than men. Okay. So this again breaks things into quarters. The longer the quartile piece is, the more spread out your data is. It's like a range, right? You're spread out more in that section. Okay. So that's practice with Statcrunch, 5-number summary. Let's do the last couple questions I have on here. If I look at just times of women from problem six, and my wait time is 205, what is my Z-score for about the time of 10 minutes? Okay, what about, oh. I didn't write that question well, and I don't even have a period at the end. Good thing I don't teach freaking English. Okay, so if we are taking 10 minutes, well, we have to go back to our data, and I need to know the mean, and I need to know the, oops, I think I went to the wrong thing. There it is. Let me go back so I can make sure you're seeing me. I need to know the mean and the standard deviation, right? To be able to do this Z-score. So I'm going to hit stat columns, tell it I only want women because this question has women. I slide that off on an iPad. On your computer, you have to click over. And I don't want the typical 11 things it has. I just want these two. Man, I like it on the I like Statcrunch on here. Did you know you could also open Statcrunch on your phone and use it while you have your computer open for like that double screen? And I'm on an iPad. You could do it on an iPad too. So I'm going to compute. There we go. There's our mean and standard deviation. So if it took 10 minutes, I thought this was in seconds. Yeah, our data is in seconds. No, it's because it's not 205 minutes. Okay, so I'm going to write down this mean. I was like, I need to convert my 168.42, and my standard deviation is kind of that S symbol because it's of the pop thing here. So 3, 4. Okay, so we got that. If we look back, this is in seconds. I don't know if it says it on there, but yeah, this is in seconds. Okay, so if I have 10 minutes, oh my gosh, that is way too long. So I'm going to take 10 minutes and put it in seconds. This is not seconds. By the time you see this problem, it will have the data set on it, and that will say seconds, and I will make it worded better by the time you open this note packet. Okay, so 10 minutes times 60 is going to be 600. So this represents 600 seconds because they have to all be in seconds for us to do that. All right, so Z-score 600 seconds minus the mean 168.42 divided by the 87.34. So minus, I got to do some calculator, 168.42, and then divide that by 87.34. Make sure you subtract, hit enter, then divide, or use parentheses around the top, or it gives you the wrong answer. Hold on, I did it a little bit. I forgot to push divide. 87.34. I did it too quick. I get like 4. That's such a big Z-score. Yeah, that Z-score is huge. So if we take 10 minutes, that is way above the average. Okay. So that problem didn't come through as pretty as I would have liked, but there you go. Okay. List the 5-number summary and list the outliers from this. So can you look at a graph and come up with the 5-number summary? Well, the lowest values here, we're going to have to estimate. So the lowest value is what, maybe 41, 40. It looks about 41. Okay. The second one is your quartile 1, right? Right here, quartile 2, excuse me. No, 1. This is considered Q1, Q2, Q3, and then this is the max, and this is the min. Okay, so the second number, well, okay, this is a little tricky, right? Because the max is actually this one. Right? Because the max is actually one of the outliers. Okay, so 2, we have about 55. Okay, 3 is 1, 2, 3 is the median. I don't know, maybe 64, 63, somewhere around there. And then Q3 is going to be, looks like about 70. If you had to do these exact, it would be better. It'd be easier to tell, but, and then the last one, the max, is going to be at whatever this would be considered, what, 100. So the max is that actual 100, and you have 2 outliers. And the outliers were 95 and 97. I don't know, 95, 97-ish. Okay, so you had 2 outliers way above, but you see what I mean by that, the 5-number summary, the max still is that outlier. That still is the highest number. This is the 3rd one down that it's using in that modified box plot. Okay, so I'm trying to remember if you go this way, I don't think it'll have an outlier so that it's easier to find that on the ones that you do in your homework. Okay, that's all I got for this section, I think. Oh, I'm just kidding. One more. What is the percentile? What percentile is 3.4? Okay, where is 3.4? Right here. How do I find what percentile this data value is? I count how many data are below it. So 10, 20, 22, 23, 24, 25, 26, 27. So there's 27 data below. And we divide that by the total, and there's 50 in this because it's easy to count. So 20, I found that your book uses 50 data for a lot of this, and I stole this all from the book. Is 0.54. So that's the 54 percentile-ish place. So how many are below divided by the total? I don't think in Statcrunch it will do the values, the percentiles for you. So stat. I don't know. You might be able to find it in here. It'd be under columns, I would think. Maybe not. Skewness. Yeah, I don't think you could do that on Statcrunch. But all right, guys, have a good one.